Okay, today we're going to go over the laws of exponents. We have three major laws that you need to know for what we're doing. Okay, multiplying powers. So, when you have two exponents, or known as powers, and the base is the same. So if you notice the x is the same here. When multiplying them, it's easiest to just write the same base, when we're going to simplify the question, and add the two powers together. Okay, an example of something like this would be 5 to the power of 4 times 5 to the power of 3, which would become 5 to the power of 4 plus 3, okay, which is 5 to the power of 7. Dividing exponents. Same idea. If our bases are the same, we write it as one base and we just subtract the two powers. So let's use those same numbers. Let's say we had 5 to the power of 4 divided by 5 to the power of 3. That would be equivalent of 5 to the power of 4 over 3. We always take the exponent of the numerator, or the number on top, and we subtract that from the denominator's exponent. Okay, 4 subtract 3. And finally, a power of a power. That's when we have one exponent to a power, and that bracket itself is to another power. The best way to simplify that is just to multiply the two powers by each other and leave it as a base. So, same idea. Let's say we have 5 to the power of 4, and all of that is to the power of 3. We end up with 5 to the power of 4 times 3, which is what? 12. Okay. I didn't actually do the last step of simplifying. You're going to need to do that. So let's get into a couple examples of this. The very first example, they've given us 5 to the power of 2 to the power of 4. Okay? Just to make sense of the last power rule, because I know a lot of people have issues with it, when we have a power of something, what it's saying is you're going to multiply the base by itself that many times. So in this question, it just so happens 5 to the power of 2 is the base. So if we were to rewrite this, it would be the same as writing 5 to the power of 2 times 5 to the power of 2 times 5 to the power of 2 times 5 to the power of 2. Each of those would be 25. You multiply by each other, okay? Now, another way we could simplify this is I've now turned this into a multiplying powers question. If you guys notice, right? These are all powers with the same base multiplied by each other. So we could simplify those by just adding all of the exponents together. So this then becomes 5 to the power of 2 plus 2 plus 2 plus 2, which is, anyone know? 8. That's right. So we have 5 to the power of 8. The fast way we could have done this is if we'd recognized this was a power of a power, we would have just written 5 to the power of 2 times 4, which is 8. Okay? So that's the idea of a power of a power. That's a good example of that one. Second example we'll go through. Let's say we have 3 to the power of 4 times 3 to the power of 8 divided by 3 to the power of 7. Okay, BEDMAS. What do I deal with first, according to BEDMAS? Yeah, brackets. Are there really any brackets? We're trying to simplify as a power. Okay, so I actually don't want to give this a number value. So there's no brackets to deal with, and everything's an exponent. What are the two major operations we're looking at right here? Division is one, and... Okay, which one do I deal with first? Why?
Bracket.
You're way behind. Okay. Okay. We already talked about the bracket. We can't simplify it. Focus. All right, so like Jose said, we have two. Division and multiplication, or maybe it was Mark. I can't remember which one. Maybe it was Mark. They both fall, according to BEDMAS, at the same level. So because in English we read left to right, we deal with what's to the left first. So we're going to deal with the multiplication first. The multiplication has two bases that are the same. Okay? So we could simplify those two bases by just writing the same base, the number 3, and adding the two exponents together. Once we've done that part of the process, we'll then have to divide by 3 to the power of 7. What is 4 plus 8? Thank you. 12. Divided by 3 to the power of 7. Well, now I have a division question, and I really should have had equals all over here. How do I simplify this? Subtract. That's right. That's good. So we take that base 3 and we subtract the 2 exponents 12. Subtract 7. We end up with 3 to the power of 5. Okay? That's the second example. And we'll quickly go through the third. I know we usually only go through one, but these are pretty straightforward. Very last one has 6 times 6 to the power of 7 divided by 6 to the power of 3 to the power of 2. Now, this is written a little differently than you guys are used to. Technically, we do need to use bedmass first. Because this is written like a fraction, think of it like they want you to equate the entire top of the fraction and the entire bottom of the fraction separately, and then divide at the very end. Okay, so the dividing part is going to be the last step we're going to deal with. The first step, according to bedmass, is we're going to deal with what's on top. This 6 is technically to what exponent? 1. Okay? And the bases are the same, so how do I simplify that? That's right. We write it as 6 to the power of what? 7 plus 1. Because technically there is a 1 there, we have 6 to the power of 1 plus 7. Still divided by, we're going to do that last. The bottom part, this is a power of a power. How do I simplify that? We multiply the two powers. So I have 6 to the power of 3 times 2. Good, you guys already know, so we'll jump down. This becomes 6 to the power of 8 divided by what? 6 to the power of 6. How do we simplify this? Yeah, we're going to subtract, and you guys someone already said the answer. 6 to the power of 2. That's everything we've done. Your work today is to simplify things like this. It's pretty straightforward. You just got to get used to those rules. Right at the 50.